Hello, this is Abubakar Abdulkader from Physics Department, one of your tutors that will be taking you on Physics 121 General Physics. So on my own side, I'll be taking you on the following. The first thing we're expected to know on my own side is reflection. The second is plane surfaces. Then you have reflection of light at a plane surface. We'll also see loss of reflection. We'll study principle of reversibility of light. We'll also study how image is formed on a plane mirror. We'll also proceed and see characteristics of the image formed by a plane mirror. Then lastly, we'll see where we can apply reflection at plane surfaces. So the first one we have there, we can see reflection and plane surfaces. So in a simple term, what does it mean by reflection? One word that can replace reflection, we can say a bounce back. A bounce back. You have a ball, a lawn tennis ball, you throw it to the wall, and the next thing you see, it hits the wall and it gets back to you. That's an example of a reflection, a bounce back. Now I have a picture there to illustrate how it is being done. You have a ray of light falling on a smooth surface, and then the next thing you see, it reflects in a different direction, a bounce back. Now the next thing we have there is a plane surface. What is a plane surface? We said a plane surface is actually any flat surface. It's a flat surface and it has to be two-dimensional. A flat and a perfectly two-dimensional surface. That's what we call a plane surface. Then the next thing, having known reflection and a plane surface, let's look at reflection of light at a plane surface. The words there are reflection, light, and a plane surface. We already know reflection to be a bounce back, and we also said that a plane surface is actually a flat surface, a two-dimensional surface. Now the new thing there is light. Now this light could be from a source called a torchlight maybe, or it could be from a laser. That's a light coming from a torchlight or light from a laser. Then what happened when this light actually fall on a plane surface? Now you can see I listed three things, three behavior. Three things are likely to happen when light falls on a plane surface. It is either absorbed, transmitted, or it gets reflected. Sometimes a combination of any two or all the three can happen. Now for the sake of our knowledge, for the sake of our class, we are expected to study reflection, not transmission and not absorption. Now we have two types of reflection. One is the regular reflection, and the second could be a scattered or a diffused reflection. Now let's look at the first one, which is a regular reflection. You have it as, you can see we have a plane surface that has been coated below. Now parallel ray of light are coming from a particular source. Once they hit on the smooth surface, you will observe that they travel along the same direction. That is, parallel rays incident on a plane surface are reflected parallel along the same direction. Now on the other side, where you have diffused or a scattered reflection, you can see that the ray are parallel, coming from a source, and on falling on the rough surface, they get reflected through different direction, unlike the regular reflection. They move a different direction. You can see the diagram, the second diagram there. Now, that particular surface, that particular smooth surface that can actually give you a regular reflection is a plane mirror. Now, what is a plane mirror? A plane mirror is actually a material that has been produced or that is produced by coating a plain glass with silver. So that silver serves to prevent light from passing through. It allows for only reflection. That's how the plane mirror works. Now let's proceed to let's study plane mirror. Let's study loss of reflection now. We have seen how light or how a surface behaves when light actually falls on their surface. We said, one, it gets absorbed, transmitted, or reflected. We also said that for the sake of our study, we are going to study only reflection. And we said we have two types of reflection, a regular reflection and a diffused reflection. And we said an example of a smooth surface that can allow for reflection or a regular reflection is a plane mirror. Now, and we said, what is this plane mirror? A plane mirror is actually a material which you produce by coating a plain glass with silver. And the function of your silver is to actually allow light to reflect and not to get transmitted through. Now, we've been discussing reflection. It's no longer a new word to you. Now, let's look at the laws of reflection. One of the law states that the incident ray, the reflected ray, and the normal at a point of incidence, they all lie on the same plane. Now, if I should explain the first law there, let's look at this. This is a smooth surface. Let's suppose, I coat it. Now, this is my reflecting surface. The next thing, I want to demonstrate the first law that says incident ray, reflected ray, and the normal at the point of incidence, they all lie on the same plane. Now, this is my plane. The next thing, I will draw a normal. A normal is a line which is drawn to dissect your plane at 90 degrees. So you can name it N, or you can write it in full as normal. Now, you can name this particular point where it actually hits the plane surface. Let's call it point O. Now, the next thing is an incident ray. So we have it this way, on the same point, carrying an arrow. Let's label it as, say, A. So OA is actually our incident ray, and this point is the point at which my incident ray falls on or hits. Now, what happened? You are expected to have a reflection. This is called a reflected ray. Let's call it B. So it means the first law is telling us that the incident ray, that is the incident ray, the reflected ray, and the normal at the point of incidence, this is their point of incidence, they all lie on the same plane. That is what the first law is telling you, that the incident ray, the reflected ray, and the normal at the point of incidence, they all lie on the same plane. Now, the next law is saying that the angle of incidence and the angle of reflection are equal. Now, look at my diagram. This is the incident ray. In between my incident ray and the normal, I have a distance, an angular distance. I will name it, let's say, I. This I is the angle of incidence, that is the angle between the incident ray and the normal is I. Now, Similarly, you also have a distance, an angular distance between the normal and the reflected ray. This particular angle is called the reflected angle or angle of reflection. Now, what this second law is saying, that the angle of incidence and the angle of reflection are equal. So in summary, laws of reflection are the incident ray, the reflected ray, and the normal at the point of incidence. They all lie on the same plane. Secondly, the angle of incidence is always equal to the angle of reflection. That is, I is always equal to R. This is the law of reflection. Now, let's look at my diagram again. This is my diagram. Originally, without a reflection, if this ray were to transmit or were to pass through the plane surface, it should go down straight without deviation. But as we will have it, this is a plane surface, this is a mirror capable of reflecting an incident ray. Now, if we are to account for how much our ray has deviated from its original path, we can actually account for this particular angular distance, just like we did for I and R. So we have this to be a distance, an angular distance. So let's call this distance this, or we can call it theta. So our interest now is to find this theta. This theta is called the angle of deviation. So how do we find this angle of deviation? That is, how do we account for how much our incident ray deviates from its original path? Now, let's use a simple mathematics here. Let's suppose we produce this line downward. Now, look at this. I have something like this. This is it here, and this is my normal. This is my normal, and this is the other side. Let me call this one, this is O, this is C, and this is what? D. Now, I have it this way. Let me call this one, okay, this is D now. Now, this is my reflected ray. In between, you have your R. I have it this way, and I have my incident ray. You have your I here. Now, if I produce this downward, I have this to be, this is my angle of deviation now. Now, you will believe me that we are interested in looking for the distance between this place and then this place, but we have to account for what this particular angle is. Then to do this, we know very well that if you have something like this and then you draw a line this way, if this is going to be I, then this particular angle should also be what? I. This is mathematics. If this is I, then this should also be I. Now, if at all this is I, then this one should also be what? I. So we have it as this is I, this is R, then the whole of this is our angle of deviation, which is theta, and then we have this to be what? I again, as a result of this angle. Now we are interested in looking for I, which is our angle of deviation. So how do we do it? Now we can ignore the whole of this area. We can ignore it this way. If you can see me, we can ignore it. Now, how to look for this? We can say angle on this is a straight line, and we are told that angle on a straight line is always equal to 180. So therefore, I can say this is the first angle. R is equal to, R plus theta plus I is equal to 180 degrees altogether. So our interest now is to find this angle of deviation. So I can make this theta to be subject, which is equal to 180 minus R plus I. Minus R minus I. Now I can also do it mathematically as 180 minus, I can factorize this minus negative sign outside. I have it to be I minus, or R minus, R plus I. This is mathematically correct. when you factorize this negative outside. You have a negative here, it becomes r plus I. By the time you open this bracket, you end up having what you have previously. Now, I can also proceed and say this is 180 is equal to 180 minus r plus I. We said one of the laws of reflection is that I is equal to r. Therefore, I can say in bracket r plus r, which is equal to 180 minus 2r. Or you can also say is equal to 180 minus 2i. It's either 2r or 2i, meaning the angle through which your ray deviated from its original path is actually equal to theta equal to 180 minus 2 times the angle of the incidence. This is how to find angle of incidence. Now, the next thing after this, we are going to study the principle of reversibility of light. So what does this principle mean? The principle of reversibility of light states that the path through which a ray of light travels can be reversed, and this is true for both reflection and refraction. We have a diagram on the side. Let's see how it works. Let's demonstrate how it works. Let's take the first one, which is the angle. Fine. This is principle of reversibility of light. We said it's true for both reflection and then refraction. Now let's pick reflection as our first case. We have our smooth surface as usual. Now this is our point of reference where you have your normal and you have your incident ray and you have your reflected ray. Now what this principle is saying, that the path through which a ray travels can be reversed. This is called a ray of light. When you have something like this is called a ray of light, and they become, two of them become beam. Now having it as one, we call this a ray of light. So what this principle is saying is this, that the path through which this ray will travel can be reversed. So how do we illustrate now? Let's label this A and B. This is our plane surface now. Our plane surface is AB. Now let's call this point P. Let's call this point Q, and this is R. So therefore it means that our incident ray is actually QP. Now any ray of light QP traveling along QP at a point P will, after reflection, pass through PR. Now at the same time, if at all you have a ray of light coming from a source, this ray of light is coming from a source here. Let's say this is our torchlight or any whatever source. It's coming from this direction and traveling along QP. Then after reflection, it is expected that it will travel along PR. Now this principle is telling you that should in case this source is now swapped from here and then here, then you are expecting that this ray, if at all, it will travel along RP. Then it will also, after reflection, travel along PQ. You indicate the arrow just like this is the first arrow, and then it should be this arrow. So this first arrow is telling you that the ray is actually traveling along QP and then reflecting and traveling along PR. Then according to the law, that if you swap the source, that the ray will also travel along the same path, that is along RP, then after reflection will travel along PQ. This is principle of reversibility of light. The same thing when you have refraction. Though we've not studied refraction, let me give you in a skeletal explanation. Now you have your point like this, you have your normal, then you have a ray of light like this. Then you are expecting that when it gets here, it will bend towards the normal, this way. Now, the same thing applies, that if a ray is traveling along this direction, then it gets reflected through this direction. Then if you are to swap the source, it will also travel along the same direction, just like the other one is. So this is just the principle of reversibility of light. So we can also proceed to see the next thing we have. We can see image formation by a plane mirror. How is image formed when it comes to a plane mirror? How is an image formed? Now here we are going to study how to locate the image of an object using a plane mirror. We can see on the side there is a diagram there. We'll use this diagram to explain what it means, but on how we can locate the image, or how an image of an object is formed. Now, to demonstrate that, it is a common experience. We all have a mirror in our houses. Now, when you stand in front of a plane mirror, the mirror you do your makeup on, you have your mirror right in front of you, you stand or you are seated. What you will observe within your mirror is you inside. Now, the you inside is called the image of you, while you standing outside is called the object. Now, how then do you account for the distance of your image inside of the mirror or behind your mirror? And how do you locate your image? Now, this is made possible using a ray diagram. Now, the setup, the arrangement is such that you have a plane mirror right in front of you. Then you coat, this is the coated side, this is the reflecting side. So this is where the object is standing. So let's suppose we have a candle here. This is a candle. I have a candle here. Let me name it O. This is an object now. Our object is the candle. Now this is, you are expected that your image should be formed behind the mirror, even though you can see the image of you inside the mirror. But if you are to draw it, you are to draw it behind the mirror. It's not like behind, because if you check behind, you won't see anything. But to draw it, you are to indicate your image outside, like behind the mirror. It's not actually behind. This is more like the inside of the mirror. Now, you are an observer standing or located at some point, let's say E. This is an observer now at point E. Now, you have an object standing in front of a mirror. You will agree with me that the image of this will appear inside of this your mirror. Then our examination here is, where do we place our object? Sorry, where do we place our image behind the mirror? Where? So that an eye which is at E will see the standing image behind. How do we do it? How to do it is this. Now, to this observer which is at E, there are two incident rays coming from the tip of the object. The first one, let's call it OA. That is the incident ray coming from the tip of the object, OA. Another from the same point, from the same tip of the object, falling on a point B, like that. Now, after reflection from the surface, they travel along C and then D to the eye. They will travel along CD to the eye as seen. Now, if you look at this, my two reflected ray, you will see it is forming a form of V shape, like it has scattered a bit this way and then this way. If you notice very well, you see it this way. Now, how then do you locate the image behind? Now, drawing the two reflected rays, producing them backward to meet at a point, will give you the exact location of where your image is placed. Then how do you do it? You look for your ruler and then draw a dotted line. You extend it backward. The point of intersection of these two reflected rays gives you the position of your image behind the mirror. Now, how then do you draw image formed by a plane mirror? You are expected to draw this continuous line. This is the image. It should look different to the object. An object is continuous while an image is discontinuous. So what we have done here basically is we already know that an image of an object will always show whenever an object is standing in front of it. So our point here is, where do we actually locate our image? Like, at what distance will the image formed? Now this is done by using a ray diagram. And how it's done is this: that two rays will come from the tip of the object and then strike the mirror at a point A and then B. After striking, you are expecting that there is going to be a reflection, and then they will travel along C and then D to the eye. Now, the location of your image is when you produce these two reflected rays backward. So the point of intersection of the two reflected rays gives you the position of your image behind the mirror. Yes, this is also true. Let's suppose we have a straight line from the tip. Again, when it goes straight, using our principle of reversibility of light, this will suffer no deviation. Why? Because it is not at any angle. This is just more like a normal. Normal suffer no deviation. So whatever goes this direction will get reflected and travel back through the same direction. So let's suppose this is our N now. This our mirror should be our N. So any ray of light that is actually moving from O and then in the direction of N, that is ON, will get reflected through the same direction as NO. This is principle of reversibility of light. Ray ON travel this direction will get reflected back through the same direction, that is ON and then NO. Now if you produce this backward, the same distance, what is happening here will also, whatever happens here, this is a mirror, there is going to be an image, the opposite of it behind. So the same thing happens.